Hello all, welcome back to my YouTube channel all about VLSI. In this particular video, we are going to discuss few interview questions related to AHB protocol. And this is a series where we are going to discuss interview questions related to AHB protocol. And if you're not aware of AHB protocol, I recommend you to go through our channel and you can find out AHB protocol batch 2 and you can refer to that particular recordings, right? Yes. So without wasting any time, let's see the first question. You can see the question, you can pause the video and you can resume the video for cross verification with your answer, right? So the very first question is a master performs INCR4 after beat 2. The slave inserts two wait states. So what is going to happen to the H trans in beat 3 and beat 4 is your question. So think about it, pause this video and you can answer it. Yes, I hope you have answered this particular question. Now let's see what is the answer. So basically, the beat 3's address is placed on H address during beat 2 only. If you know about AHP protocol, you might have known that AHP protocol is a pipelined protocol. That means, let's say if this is my clock and if I'm going to have a 4 beat data that I should send. Let's say it might be an INCR4 or it might be a WRAP4. That's not a issue over here for this particular question. So let's assume it's an INCR4, right? So in the first cycle, what is that we are going to do? We are going to provide all the particular the control signals and address signal, not the data signal. We are only going to send the control and address information in the cycle number one, right? And in the cycle number two, we are going to send the data, right? This is my cycle number two, and I'm going to send the data information. And in the cycle number one only, the H trans information was sent, right? And I'm assuming that in the cycle number one, my H steady was equal to one, right? And this is the reason cycle number one is known as address phase and the cycle number two is known as data phase for my beat number one. And this cycle number two is also going to act as an address phase for beat two. So that's the reason here in the case of my second cycle only, I'm going to provide the H trans information and all the control information and address signals in the cycle number two because it's the address space, right? Now, what is the question over here? So after beat two, the slave inserts two wait cycles. So let's say here in the data phase, you have completed the beat two by performing the data also, right? And this cycle 3 is also going to act as an address phase for beat 3. And that's the reason it is going to send the H trans information and address information and all other informations. Now, what is the question? So here in the fourth cycle, that is after completing beat number 2 in the fourth cycle, what is going to happen? Your H ready is equal to 0. For this cycle, H ready is equal to 0. And next cycle, that is for 2 cycles, H ready is equal to 0. In this 2 cycles, if H ready is equal to 0, what is that going to happen is the question. So as we know already, the protocol insists that if your HTTP is equal to 0, whatever the information, the address information and the control information which was given in the address phase should be constant. So that's the reason your H trans and H address, everything will be constant in this cycles. So that is what the answer is also saying. So B3 address is placed on H address during the B2 data phase. And with H radiot is equal to 0, those address phase signals are held stable. So H trans stays ASIC only, and the slave must not sample data while H ready is equal to 0. Once H radiot is equal to 1, the pipeline resumes and ASIC big beats 3 and 4 completes normally. So this we have elaborately discussed in our playlist also in our course. So you can once check it out if you haven't watched this particular thing, right? Yes. So let's move forward with next question. Now, can you state the difference between single INCR, INCR4, 8, 16 burst types? When to use INCR over INCR4? This is your question. You can pause this video, you can think of the solution, and you can resume for cross verification. Yes, I hope you have answered this particular question. So basically, single burst or single transfer is exactly one transfer. So INCR increment burst of undefined length. So if you are going to use single transfer, you are going to only send only single data. Whereas if you are going to use simple INCR, it is undefined length. So you don't know what is the number of beats you are going to send in this case of burst, right? But in the case of your INCR4, INCR 8 and INCR 16, you are going to know how many number of beats you are going to send, right? And it is fixed length. This is non-fixed length. So basically, undefined length, INCR is nothing but undefined length. And this undefined length is useful when the total count is unknown and at the burst start. For example, DMS scatter gather. And whereas INCR 4816 fixed length allows slaves to prefetch and optimize. So this is where you're going to use your INCR and INCR 4816. And we are going to use INCR when the count is data dependent, use fixed length when the count is known for better slave throughput. So this is the cases where we are going to use INCR, INCR 4860. Now let's move to the next question. So explain H response 1 down to 0, describe the mandatory 2 cycle error response. And cycle 1, we are going to give H ready out is equal to 0, H response is equal to 0, 1, that is an error. And cycle 2, release ready, that means H ready out is equal to 1 and H response is equal to 0, 1. What is this 2 slave response, and explain about this? Yes, I have. I hope you have answered this particular question. So basically, if H response is equal to 0, 0, it is okay. And if it is 0, 1, it is error. And 1, 0, it is retry. And split is 1, 1, right? Now, here, if you have studied about this AHB protocol, you might have seen this error is a two cycled response, where in cycle 1, you are going to provide the error response. H response is equal to error. And when you're going to provide it, you should make your H ready out is equal to 0. So this is what protocol is going to specify. When your H response is equal to 0, 1, first of all, you need to queue that particular response with H ready out is equal to 0. So that master is going to have some time to see error before the pipelining advances. So that's the reason we are going to provide the error response with by making our H ready out to 0. This is what slave is going to do, not the master. The slave is going to provide it so that master is going to have some time to sample it. And in the next cycle, by providing this H response to 0, 1 only, you are going to make your H ready out is equal to 1 so that master is going to complete this particular thing. And master must abort the remaining burst transfers on receiving the error. So this is the answer for this particular question, right? Yeah. So that's about this particular session. If you like this video, please like, share, and subscribe to my YouTube channel all about VLSI, and we are going to discuss few more questions in upcoming series. Thank you for watching this video.